Move on to the next slide. That is, during this radioactive decay, they produce this alpha, beta, gamma radiations. So, in case of alpha radiations, how these are differentiated? That is, alpha radiations and beta radiations, or alpha and beta rays, they are particulate in nature. That means they are particles. They are some type of particles. And gamma rays, they are electromagnetic waves. And what is the difference between particles and waves? They are particulate. That means alpha and beta rays, they are particles or particulate in nature. That means they are mass. They are having some amount of mass. And gamma rays, they are massless. They, in case of waves, they are massless, and if they're particles, they have some kind of mass, and they are like localized area or restricted to one spot, like that. In case of waves, they are not restricted to one spot. They can move. Means they have the ability to penetrate tissues. And that is the main. They have the capability to interfere with the living tissues or water, or in whatever medium they are moving. They have the ability to interfere. But in case of particulate or particles, they do not interfere, or they are localized to a specific tissue. They cannot penetrate. They have the least penetrating capacity since they are particles. Okay. This alpha rays, they carry two positive charges. Their charges plus 2, and the beta rays, they carry either a positive charge or a negative charge, so their charge will be plus or minus 1. And in case of gamma rays, they are generally uncharged. They possess charges 0. Okay. And in the alpha rays, these particles constitute two protons and two neutrons. Particles consist of two protons and two neutrons. In the case of beta rays, they can be positron or negatron. Means they can have a positive electron as well as a negative electron. They can exist as both positron and a negatron. Okay. In case of gamma rays, they are electromagnetic waves with shorter wavelength than X-rays and neutral due to the presence of protons. They have neutral charge, and they wavelength when compared to X-rays. Then, in case of alpha rays, they have this mass number is 4 AMU, similar to helium. In case of beta rays, are having negligible mass. That means 1 by 1836 of hydrogen ion. That means they are having negligible mass. Whereas gamma rays, they are having no mass. Okay. And next point is important. That means they are having least penetrating power and greatest ionizing capacity. That is, in case of, as I said earlier, alpha and beta rays are particulate in nature and gamma rays are waves. They are electromagnetic radiations, EMR, or waves. In case of gamma and beta rays, they are, since they are particulate in nature, or since they are particles, they will be having least penetrating power. Because gamma rays are waves, they will be having penetrating power. You might have already learned about rays before, or waves before. They means they have penetrating power, or they can penetrate whatever matter they are traveling through. So, in case of alpha rays, they have least penetrating power and greatest ionizing capacity. What is ionizing capacity? Ionizing capacity is the ability to interfere. Means this ionizing capacity helps the particles to interfere with the living matter. If it is the living matter, they will form. They will form chemical bonds, and it will create ions. That is the main thing. We can break the chemical bonds and forms ions. That is, the ionizing capacity means the this alpha rays can break this chemical bonds that are present in the matter or medium which they are traveling through. If they are traveling through a living tissue, what happens is they can break the chemical bonds in that matter or living tissue and forms ions, and they can form ions. Though, so they have the greatest ionizing capacity. This ionizing capacity is could be considered as positive and negative, because this ionizing capacity, what it gives us, this ionizing capacity forms mutations in humans, and it can lead to cancer. So alpha rays are more, or it is having highest carcinogenic capacity. Okay. In case of beta rays, this penetrating power is greatest when compared to alpha rays. When we are comparing alpha and beta rays, they are having more penetrating power than that of alpha rays, and they are possessing moderate ionizing capacity, not that much as that of alpha rays. The ionizing capacity will not be that much as that of alpha rays. And in case of gamma rays, they will be having highest penetrating capacity into the bones, organs and tissue, but they are non-ionizing. They won't ionize, or they are non-ionizing. They won't ionize the living tissues. Okay. Or they won't break the chemical bond and form ions. They won't help in breaking the chemical bond and form ions. Okay. The alpha rays get deflected by a strong magnetic field. The alpha rays, when compared to the deflection in the magnetic field, different like deflection produced in the magnetic field, alpha particles get deflected by a strong magnetic field, and beta particles get deflected in the presence of magnetic field, and gamma rays are not deflected in the presence of a magnetic field. This is the difference between magnetic field in case of ionizing capacity and penetration, and in case of mass, and in whether they are particulate in nature or whether they are present as waves, and in case of their charge. Okay. Here in this section, we can, as I described in the previous slide, here it is an image showing the penetrating capacity of alpha, beta and gamma radiations. Here you can see that alpha rays has least penetrating power. Cannot even penetrate a paper. In case of beta rays, it can penetrate paper as well as thin plates of wood, aluminum, etc. In case of X-rays and gamma rays, they can penetrates both paper, plates of wood and aluminum, as well as lead, iron, etc. They have the highest penetrating capacity, and they can only be controlled by means of lead, iron, and or other thick metallic plates. Otherwise, we cannot control these type of radiations. Okay. Next, we are going to deal with the emission of alpha particles, how during a radioactive decay, how they are produced. Means, in the case of alpha particles, what it does is they result in a daughter nucleus with an atomic number less by 2 units and mass number less by 4 atomic mass units, so that they will during the radioactive emission, this alpha particles helps in the creation of this daughter nucleus with atomic number, they will have the atomic number less by 2 units and mass number less by 4 units. Okay, and also 2 protons less than the original nucleus. The atomic, it will thus during the radioactive decay there will be having an original nucleus, they will have an original nucleus which will undergo the radioactive nucleus because of the instability to create daughter nucleus. So that will result in the creation of another daughter nucleus. That daughter nucleus will have atomic number less by 2 units and mass number less by 4 units, and also the two positive charges will be less than that of the original parent nucleus. In case of beta particles, they will form a daughter nucleus with atomic number increased by 1 unit and no charge in mass number, that is no change will be there in mass number will be same that of the parent nucleus, they will have the same charge as that of the parent nucleus, there will be no change in mass number, that is the atomic number will increase by 1 unit when compared to the parent nucleus. And in case of gamma rays, it will result in the lowering of nuclear energy but no elemental charge. Elemental charge will not be changed. And here we have some examples of alpha particle radioactive decay, that is radioactive decay of radium yielding radionucleus by emitting alpha particles. In case of beta particles, radioactive decay of carbon yielding nitrogen with the emission of beta particles. Next, we are going to this diagnostic applications of this radio waves. That is, radioactive tracers emitting alpha rays are used only for the therapeutic purposes, as they liberate large amount of energy over short distances, thereby destroying the local disease tissues, and are not used as diagnostic agents. In case of alpha particles, as I said earlier in the previous slide, that is, they will have least penetrating capacity and greatest ionizing capacity, means they will cause mutations or they will cause destruction of this living tissue. Since they cause the destruction of the living tissue, they cannot be used for diagnostic purposes. In case of diagnostic purposes, for the rays used in diagnostic purposes, they should not cause any destruction to the tissue or the living tissue. If they are causing destruction to the living tissue, as in case of when used in diagnostic purpose, they cannot be used. So that is why rays are not used in any case of diagnostic purposes. Okay, they are used for therapeutic purposes, like in case of cancer therapy, etc., for destruction of this localized cancer tissues, etc. And in case of beta rays, they are employed as therapeutic agents. And why? Because they are used as therapeutic agents since they have more penetrating capacity when compared to alpha rays. And they are not used for diagnostic purposes. The same thing, they cause the skin burn same as alpha rays when if exposed to an appreciable time, and also they have ionizing capacity. But in case of gamma rays, they are mostly used as they are mostly used in diagnostic purposes, because they are having high penetrating power and they're non-ionizing radiations, or they're non-ionizing rays. Okay. So this is an example of a radioactive decay, that is the parent nucleus disintegrates to form a daughter and an alpha particle, and here the parent nucleus, the parent atom, that is named as X, will have the atomic number less by 4 units and the mass number less by 2 units. It will give an alpha particle during the alpha particle or alpha rays during the radioactive disintegration to emit the alpha rays. Okay.